Here's our sequence of numbers that we just had in the last question. It was question 7100 on page 330 in the 9th grade book. And it's that we have figure number 1, 2, 3, 4, 5, 6. We've worked out the number of cubes in each of those figures. The sequence of numbers is figure 1 has 1 cube, figure 2 has 6 cubes, figure 3 has 15, figure 4 has 28, figure 5 has 45, and figure 6 has 66. Now, I showed you a couple of mathematical ways of solving the sequence. So if you found that the last video was difficult trying to work out the triangular sequence, there is actually a mathematical way. And I'll go through that in this particular case so you get a bit more example opportunity to practice it. What you do here is you look at the number of cubes and you actually just working out this difference method. What's the difference between 6 minus 1? 5. What's the difference between 15 and 6? 9. 15 minus 6 is 9. The difference between 28 and 15 is 13. And the difference between 45 and 28 is 17. And we are waiting until we get a string of zeros, which we don't at all have yet. We can see that we've got real numbers as our differences. So then we go down and take the next level of differences. So 9 minus 5 is 4. 13 minus 9, 4. 17 minus 13, 4. So we've not got 0, but we do have the same number here. So we know that when we take the next level of differences, 4 minus 4 is going to give us 0. 4 minus 4 is going to give us 0. 4 minus 4 is going to give us 0. So all of these equations that we can make are very much dependent on this sequence. And this sequence has the form a plus b times n to the power of 1 plus c times n to the power of 2 plus d times n to the power of 3, etc., etc. And this sequence goes on forever. And how we determine how large this sequence is depends on actually how many lines we have here. We had one difference line, and a second difference line, and a third difference line, telling us that we had 3 terms here, so we have to use 3 terms in our equation. So we have to go for a plus b plus cn squared. But there is no dn cubed terms. So our equation is going to be of the form a plus b times n plus c times n squared. So we're going to get 3 equations and 3 unknowns. And the way that we work this out is we say for n equals 1. And we know that we've got an equation of this form, a plus bn plus cn squared. We have to substitute our values in that we have. A plus b times n, but we know that b is n is 1. B times 1 plus c times n squared, but we know that n is 1. So we get 1 squared. Equals. What does it equal? It actually equals the value of the number of cubes of n that we got. Equals 1. So we can readjust this equation. It gives us that a plus b plus c equals 1. B times 1 is 1, c times 1 squared is 1. So our first equation that we end up getting here, very important equation, is that a plus b plus c all equal 1. Right, to get our second equation, we now substitute n equals 2, giving us the answer 6. When n equals 2, the answer to our equation is going to be 6. So we substitute a plus b times n, sorry, n is not 1, it's 2. B times 2 plus c times n squared, that would be 2 squared, and it will give us the answer 6 that we have as the number of cubes. So let's reorganize that. So we get that a plus 2 lots of b plus 2 squared is 4, 4 lots of c is going to equal 6. And this is our second very important equation. And now we have for n equals 3. we have that a plus b times n, but n equals 3, b times 3 plus c times n squared, 3 squared would be 9, 3 squared, equals, and what's the answer when n equals 3? How many cubes do we have? We have 15. So the answer here is 50. So we get a plus 3b plus 9c equals 15. And we're going to need some more space to work out these three equations. So we will rewrite the equations on the next page. So here are three equations. A plus b plus c equals 1. I've written it in red, and we'll work out everything with equation 1 in red. Then we have a plus 2b plus 4c equals 6, equation 2. And then we have a plus 3b plus 9c equals 50. Right, we have three equations and three unknowns, so this is very easy to solve. Let's start with rearranging equation 1 so that we find out what a is in terms of b and c. Well, if we move b and c to the other side of the equation, they will become negative. Change the sign when you move from the left-hand side to the right-hand side. We'll get a equals 1 minus b minus c. So now have an expression for what a is. So in equation 2, whenever we see a, we will substitute it with the value that we have now. We know that a equals 1 minus b, so we're just going to rearrange equation 2. So up here we rearranged equation 1. Now we're going to rearrange equation 2. A we can represent as 1 minus b. Let's put it in red so it's really easy for you to see what we're doing here. So instead of writing a, we're going to write 1 minus b minus c, plus the rest of equation 2, which is plus a plus 2b plus 4c equals 6. So now we can rearrange this equation to get it in just terms of b and c. 2b minus b would give us just plus b. 4c minus 1c would give us 3c. And we have 1 over here, so plus 1 equals 6. So let's rearrange that so we get just in terms of b and c. b plus 3c equals 6 minus 1, which is 5. So what does b equal then? b by itself is going to equal 5 minus 3c. So we now have an expression for b by itself. b is only in terms of c. So what do we do with that? Well, we substitute our expression for a, which we have here, and our expression for b into our third equation. Whenever we see a, we write the red expression for a. Whenever we see b, we write the blue expression for b. So let's do that. Our equation is a, so let's write what we know for a. We know that a equals 1 minus b minus c. And then we have 3 lots of b, but we know that b, and we need 3 lots of it, so we're going to have brackets here. We know that b by itself is 5 minus 3c. So we take our value of b and put it into our equation. 3 lots of b is 3 times 5 minus 3c. Then the rest of the equation stays the same. Plus 9c equals 15. We're not quite ready yet because we've not only got c's in the number, we've also got this little b sneaking in here. Look, there's a b there. But we know that b is the same as 5 minus 3c from over here. So what we have to do to finish and tidy this equation up is we have to rewrite it as 1 minus b we can write as 5, b is the same as 5 minus 3c. Okay, then we go back to our red minus c. Plus what we know about b, which is 3 lots of 5 minus 3c, plus 9c equals 15. Right, now we can just get a long string of numbers, so we're going to change colour totally. We've finished everything now, because now in this final equation here, we only have numbers and the letter C. So now it's really easy to solve, but we just have to stay calm and do or use all our skills of just numbers and negative numbers times positive numbers to work this out. We start off with 1. Minus, in front of this bracket, is the same as minus 1 times. Minus 1 times plus 5 would give us minus 5. Minus 1 times minus 3 would give us plus 3c. Then we have a minus c in our next line, plus 3 lots of 5. 3 5s are 15, plus 3 times minus 3c. Well, a plus times a minus is going to give us a minus, and 3 times 3c would give us 9c. Plus, finish now with all of these terms, our last term here, 9c, equals 15. So we can see that the plus 9c cancels with the minus 9c. Let's count up our numbers here. We get 15 minus 5 plus 1. 15 minus 5 would give us 10. 10 plus 1 would give us 11. So we'd have 11 here. 3c minus c would give us 2c, equals 15. So we now have that 2c equals 15 minus 11, which is 4. So 2 lots of c equals 4, therefore c equals 2. 4 divided by 2 will give us that c equals 2. We now know what c is. C is 2, and we can put this value of c into our second equation, because we know that b is the same as 5 minus 3 times c, but we know that c is now 2. So b is going to be 5 minus 3 times 2 is 6, 5 minus 6 is going to be minus 1. We now have a value of b equals minus 1. Right, what do we do with that then? Well, we put the value of b equals minus 1 and c equals 2, of course, into the first equation, because we know that a equals 1 minus b, but b is already minus 1, so we get minus 1 minus c, which we know we don't write c, of course, because we know that c actually equals 2. So c is 2. 1 minus minus 1 is plus 1, so that would give us 1 plus 1, which would be 2. 2 minus 2, which would give us 0. So our equation is going to be of the form a plus bn plus cn squared. We now know that a is 0. We know that b is minus 1. And we know that c is 2. So our equation is going to have the form of 0 plus n times minus 1 plus 2n squared. Let's rearrange this equation. The equation is going to have the form that the number of cubes in our pictures is going to be 2n squared. N times minus 1 is minus n minus n. So our formula for the number of cubes in terms of the figure number is going to be 2n squared minus 1, which we already proved in the other video was the correct answer. Let's do so in this video. We now have a formula that the number of cubes, c, equals 2n squared minus n. Let's look what would happen for n equals 6. So let's go up here for n equals 6. 2 times 6 squared minus 6. 6 squared would be 36. 36 multiplied by 2 would give us 72. 72 minus 6 would give us 66. So our formula works for n equals 6. Let's try it again for n equals 5. The number of cubes for n equals 5 should be 2 times 5 squared minus 5. 5 squared is 25, 2 lots of that would be 50. 50 minus 5 would give us 45, which is the number that we do have. For the n equals 5, we have 45 cubes. So we've proved as well that our formula actually works. This is how we can use sequences to actually mathematically work out the formula, and if you find this method easier than the other method I showed you.